hydrostatic and osmotic, and then also how they both play a part in homeostasis. Hydrostatic pressure, we'll start on this side. Hydrostatic pressure occurs more on the arterial end of the capillary, so the heart pumps blood, goes to the artery and the arterioles, and then into the arterial end of the capillary. It means that pressure usually drives fluid out of the capillaries and it goes into the cell, which means it can cause them to swell. They kind of call that filtration. Don't know why, but it's this pressure is a lot higher at the arterial end than at the venous end. And the reason why is because when the heart is pumping blood and when it pushes it, and that force, that pressure is pushing blood into the arteries, all of that pressure causes the fluid to come out and to go into the cells. And that is also due to the capillaries being very permeable, so it's easy, it just goes very freely. And so you have that. And then osmotic pressure, over here, osmotic pressure occurs more at the venous end of the capillary, sorry. So it pulls the water back into the capillary. Higher at the venous end. And these particles, these black particles, they're like albumin, or there could be proteins. Albumin is just an example. Albumin helps pull the water back into the blood vessel. So then that kind of causes the cells to shrink, but not really shrink, just to shrink back to normal, unless there actually is something wrong, like a disease, then it's all whacked out. But down here, when it's all together, here we are at the arterial end, blood pushes the blood, it's pumping blood, which means it's going to cause water to come out and go into the cells. You still got these albumin that are just roaming around. Then you come more towards the venous end of the capillary, and this albumin is then going to help pull the water back into the blood vessel. And when everything is just normal, that's how it regulates homeostasis. In and out.